Okay, now we're going to look at electromagnets. What I have in front of me is a wire. I have the power supply over here. It has a very high current limit, 20 amperes, as it says there. I've plugged in the power supply. I will hook up the wires, but I haven't turned anything on yet. Now, what I have here is called a magneprobe. It has a blue side and a red side. You can see each of those sides is a magnetic north pole. That would be this red one, attracted to the south pole of my bar magnet. The other one is magnetic south, the blue one, attracted to the north side. And so I can show you magneprobe hanging out around the wire. Doesn't really do anything. Now if I turn my power supply on and I bring this back over, you can see that the magneprobe is responding. It's having a difficult time rotating, probably due to the fact that this magneprobe is in some way damaged, but you can tell that it sort of spins around. Currently, the blue side is always pointing this way. The red side points this way. If I move up towards the top, you'll see it still does the same thing. If I move down towards the bottom, it still does the same thing. Now, if I turn this back off, turn it off, the probe stops responding. Turn it back on, the probe responds again. Off, stops responding. Okay. Now, we can reverse the direction of the current by flipping the direction of our leads. Previously, we had positive voltage at top, ground at bottom. Now we'll flip it so that we have ground at top, positive voltage at the bottom. Turn that on. And here we go. Now the red is pointing around this way. Blue points around the other way. If we turn it off again, it stops responding. We can swap these again just to make sure. Right? Now blue is pointing around this way. Again, aside from this weird little catch right here, which seems to be some sort of jam in my magneprobe. You can also see it with a compass. And if I turn it off, the compass goes back to normal. So what's in front of me is a container holding a battery. Each end of the battery is attached to one of these copper struts. And this is a wire coiled around itself with stripped ends attached to those copper struts. So it's conducting at those 2 points. If I bring my magneprobe close, you can see that the red points down into it. If I bring it around to the side, you can see that it does not. Back around, red pointing down, around towards this side. You can even see that the red starts to flip up. I come in here at the bottom, blue points up, and back here, blue is pointing up, red is pointing down. Okay. And it's symmetric as I move around to the outside, though that may be unclear. What I have here is a solenoid. It is a wire wrapped around a large number of times. So this was a single wire going straight up and down. This is one wire that's been wrapped many, many times around, like so. Now I hook it up to the same supply, take my MagnaProbe here. I can show you that the MagnaProbe does not respond to the solenoid as it stands. But if I turn it on, I bring the MagnaProbe close to it, you can see that the red end points up when it's on the outside, and it points inside when it's on the side over there. When I bring it back around to this side, the blue points inside, right? If I take my MagnaProbe all the way through, you'll find that blue still points to my left, red to my right. And you can also tell that if we move around the side, you can't tell because of my camera angle. So we move around the side, the blue points to my right on the outside, in to my left on the inside, and vice versa for the red. Now, what else can we do? Well, we have a bar magnet. If this is showing us magnetic field, and we have another magnet, and we bring it close, you can predict what will happen. So, as I bring the south side towards this top end, I feel resistance. If I set it down in here, we get nothing. But if I bring the north side close, it pulls out of my hand. The opposite happens with the other side. The white side gets pulled in, the red side gets pushed back. I'm trying to balance it carefully so that it can fly off. That's the best I'm going to do, apparently. What more can we do? We can remove these leads, and we can attach with this BNC cable an ammeter. So what this will do is read the current passing through here. Okay. Now, set the ammeter so that you can see. Take my magnet and toss it through. Now you can see that the meter spiked to my right when I toss the white side through first. Oh, sorry. It spikes to my left when I toss the white side through. It spikes to my right when I toss the red side through. And I can do it in the other direction as well. Toss the red side through this way, and it spikes to the left. Toss the white side through, spikes to the right. So that means that a magnet moving through this solenoid generates current. And that's what I have for you.